Hey everyone, let's do a limit problem. I'm choosing this one from section 3.1 limits out of the exercises. It's number 52 in the book. Limit as x approaches negative 4 of x plus 4 divided by 16 minus x squared. So you might notice that if you try to do something, if you just try to plug in negative 4, well, you get negative 4 plus 4 over 16 minus the quantity negative 4 squared, and that equals 0 over 0, right? No help to us. Well, that's not totally true. We know that it's an indeterminate form. You wouldn't need to write this on a homework. I just want to emphasize that this is an indeterminate form. Just call it indeterminate form, right? So we don't know what's going on. Maybe the limit exists, maybe it doesn't. Let's take a look. Well, what we can do is we can factor. Remember, we keep writing the limit as x approaches negative 4. And we have, can you factor 16 minus x squared? It's 4 minus x times 4 plus x. That's a little confusing for you. If you like to have your x squareds be positive, then you could just multiply the fraction by negative 1 on the top and the bottom and have negative x minus 4 all over x squared minus 16, and then that's a bit easier to factor if you want. Okay? But anyway, we have this, and now we see the magic happens, right? Because x plus 4 and 4 plus x are the same thing, and now we just, we just solve it, right? 1 over 4 minus negative 4 is better known as 1/8. Done. That's it, right? Now, I just want to be clear. I mentioned this in class. The function does not exist at negative 4. You can't plug in negative 4. You get division by 0. It's not okay. But what you have is you effectively have a function 1 over 4 minus x. So, it looks, I don't know, something like this maybe. And so for certain values, as we approach, was at negative 4? Actually, I guess I should be talking about the negative part of this, right? So something like this. When we're at negative 4, we actually have a little hole right there. Right at 1/8, right? So the graph doesn't actually exist there. There's not a filled in hole. It's just a hole right there. But that's what you have, okay? Maybe let's do one more example. Let's do, 54. All right, limit as x approaches 1/2 of 1 minus x minus 2x squared over 1 minus... I don't love that one. That one's, well, no, actually, yeah, I do. I like that one. Let's see about this one. Yeah, I like this one. I like this one a lot. All right, so again, if we plug in 1/2, we're going to get 1 minus 1/2, which is 1/2, minus 2 times 1/4, which is 1/2. And yeah, you might imagine we get 0 over 0. So we must resort to factoring. Again, I keep writing the limit as x approaches 1/2. And I'm just hoping I'm able to factor this guy. Does that work? Let's see. I've got 2x times 1. Nope, think I did it backwards. I think it's supposed to be that guy, right? Because now I have the OI part of foiling. I get negative x. Okay? All over 1 minus 2x. And oh, look at that. Cancel so nicely. And we have 1 plus 1/2, better known as 3/2. Again, we have line y equals 1 plus x, and as x approaches 1/2, we actually have a hole right there. So actually the function does not exist there, but as you can see, it approaches the value 3/2. All right, so y equals, well, let's just write that guy down. Okay. All right, that's all I got for you. Thanks.